The San Andreas Fault system is one of numerous that roughly defines the boundary between the North American and Pacific tectonic plates. Recently, both plates have been moving roughly northward. But here's the thing. The Pacific plate is moving more quickly than its cousin, the North American plate. Thus, there is a steady buildup of tensions between the two plates. This has led the Southern California Earthquake Center's director to make a statement that should send shivers down the spines of all Californians. The San Andreas Fault could produce a big earthquake any time from now. Join us as we provide a detailed overview of what is to come. Formerly unknown, the story of the San Andreas Fault started with Professor Andrew Lawson from UC Berkeley, who discovered it in 1895 and named it after the San Andreas Valley. After the extremely devastating 1906 San Francisco quake, he was tasked with investigating its source. To do this, he surveyed the surface ruptures, including offsets such as fences or roads sliced in half, and plotted their locations on a map. He noticed that these offsets aligned perfectly with the FaultFault he had previously identified, leading him to conclude that the FaultFault was responsible for the earthquake. Interestingly, this discovery also led to identifying a new type of earthquake known as an intermediate depth earthquake. Although the visibility of the San Andreas Fault can sometimes be problematic, much of the San Andreas Fault's length is visible as a straight depression. This has produced a characteristic pattern of lakes, bays, and valleys. These qualities may not be immediately apparent from the ground. For instance, drivers may need to be informed that they are in the San Andreas earthquake zone as they pass close to Crystal Springs Reservoir near San Francisco, Tomales Bay, or through Cajun or Tejan passes. The location of the FaultFault on the Earth's surface can be determined by carefully examining the landscape in the area. Moreover, in some places, like the Carrizo Plain in San Luis Obispo County and the Olimatrof in Marin County, the San Andreas Fault is clearly visible as a succession of scarps and pressure ridges. Wickedly destructive and potentially still so, this FaultFault is the most dangerous in America. With the number of lives it has claimed and could still claim, there is possibly nothing like it in the world currently. Fast back to over 600 years, it released earthquakes like a mother dishing out candies to have a poor little baby. Somehow, that has since stopped for a while. In fact, current data shows that since 1857, Southern California, the hub of the fault, has never recorded any earthquake. To know how heavy the earthquake around this place can be, we are sorry to announce that the one of 1857 had a magnitude of 7.9 and resulted in damage along a stretch of about 185 miles, taking the total lives possible in that area at that time, and destroying some other things. Unfortunately, the recent drought of quakes has led many scientists to think the probability of an imminent quake is ever higher than necessary. In fact, according to some, the coming one will be a big one because of the drought. Thus, given the strains and pressure it has collected over the years, the FaultFault remains a time-ticking bomb that may devastate things. The Pacific and American tectonic plates meet near the San Andreas Fault's border. These two plates remain in constant contact, creating pressure that finally manifests as earthquakes and causes catastrophic loss of life and property. Elastic rebound is the name of the entire process. These cause seismic waves, which move through the earth and shake the surface as they collide and crash into one another. That is why the San Andreas Fault in Northern California can experience an earthquake, but not the San Andreas Fault in Southern California. Is California going to be swallowed up anytime soon? First, you'll perhaps like to hear this. The already identified upcoming large-scale earthquake, or the big one, as it is generally known, won't be this deadly California swallowing core that we are being told will happen. In light of current research in the field, except for the economic drawback it will cause, this earthquake will be far from its predecessor, the one of 1857. There are very good reasons for this. Since we do not mind keeping you in the dark, let us observe them closely. First, structures. In quakes, the death caused by structures falling apart is more than those caused by the shocks and tremors of the quake themselves. except in the case of house-swallowing ones. The Southern California administration, noticing this many years back, has embarked on a nationwide principle-backed construction of houses and other structures that will make them unable to be destroyed by quakes. This does not mean structures can be totally earthquake-proof. It just means, given the fact that the earthquake might not be that strong, and the fact that structures in California are constructed in accordance with some of the most stringent seismic resistance regulations in the world, the earthquake having an ultra-destructive impact, as is often portrayed, is unlikely. Meanwhile, state infrastructure, such as electric power, communication masts, and more, is expected to be extremely damaged by the quake since they cannot withstand it. This will stop communication flow abruptly until something is done to it. Corroborating this is people undergoing significant research. Of course, this does not mean everything is in place. Let's turn to what some scientists do to predict what could happen. First, in a bid to understand the future scenario of the quake, they adopted the 1989 Loma Prieta earthquake as a model, and the result is the same as what has been said earlier, albeit with some differences that will be mentioned later. The IT industry will experience communication problems for a very long time. But what if it is struck hard? What could happen? In that state, the 1989 Loma Prieta quake can explain many things. During the above earthquake, more than 60 people died, and another 3,800 were injured due to its epicenter roughly 10 miles northeast of Santa Cruz. A significant motorway collapse and the devastation of around 40 buildings in Santa Cruz were among the damages. To get the scenario, we must also mention that the U.S. Geological Survey reported that 12,000 residences and 2,600 businesses were damaged or destroyed throughout the San Francisco area, and that the overall cost of the earthquake was $6 billion in 1989 currency. According to John Woodall, Vice President of Engineering at Integrated Arco Systems, a Palo Alto, California-based solution provider, the roadways around the epicenter of a prospective earthquake area could impede recovery efforts due to the state's substantial population, especially so in the case of the San Andreas Fault. The danger becomes even more apparent when you realize that the FaultFault lies on the boundary between the American and Pacific tectonic plates. This is regarded as the most dangerous. Why is this so? The FaultFault runs directly through cities, including Desert Hot Springs, San Bernardino, Wrightwood, Palmdale, Gorman, Frazier Park, Daly City, Point Reyes Station, and Bodega Bay, which makes them vulnerable to earthquakes at any time. In the case of the big one, consider them gone. When could the next earthquake occur along the San Andreas Fault? Every year, thousands of minor earthquakes in California give scientists a clear idea of where faults in the Earth's crust are. The earthquakes in 1857 and 1906 were the two greatest ones recorded along the San Andreas Fault. The Southern California earthquake of January 9, 1857, had a similar magnitude to the 1906 San Francisco earthquake. According to newspaper accounts, ground movement in both situations was comparable. A sheep coral cut by the FaultFault was described as changing from a circular to an S form in the history of the 1857 earthquake. This movement is unmistakably indicative of a right lateral strike slip. Analyses of offset stream channels show that in 1857, activity reached a height of up to 29 feet. This sparked a flood of research on the San Andreas Fault, greatly advancing our knowledge of the FaultFault and general geology. Over 3,000 studies on the problem have been published in the previous 24 years alone. Over 700 people died from the San Francisco earthquake and fire on April 18, 1906. Millions of dollars were damaged throughout California, from Eureka South to Salinas and beyond. Even central Nevada and Oregon could feel the earthquake. The 1906 earthquake, recorded as having a Richter scale magnitude of 8.3, produced intensities as high as 11. A 250-mile section of the FaultFault, from San Juan Bautista north, across Point Arena, and offshore to Cape Mendocino, experienced surface offsets. A 7.1 magnitude earthquake struck the Imperial Valley on May 18, 1940, along an unidentified fault. During an earthquake in November 1979, the Imperial FaultFault experienced a similar movement. The largest surface displacement was the right lateral strike-slip displacement of 17 feet during the 1940 earthquake. This FaultFault is undoubtedly a component of the San Andreas system. On the Hayward Fault in 1836 and 1868, as well as on the San Andreas Fault in 1838, there were further earthquakes with probable magnitudes of 7 or higher. There are sections along the Earth's plate boundaries, like the San Andreas Fault, where no significant earthquakes have struck for a long time. Scientists refer to these sections as seismic gaps and have generally been successful in predicting when some seismic gaps may result in significant earthquakes. According to geological studies, the southern San Andreas Fault has experienced significant earthquakes during the past 1400 to 1500 years at intervals of roughly 150 years. The south of the San Andreas Fault is a plausible spot for an earthquake within the next several decades, because the last significant earthquake occurred in 1857. Even though it has just been a little over a century since the devastating earthquake of 1906, the San Francisco Bay Area is still susceptible to moderate-sized, potentially destructive earthquakes. The necessary fuel for a large earthquake of the magnitude of M8.0 has been built up over 159 years and 26 feet of tectonic displacement. As the strain becomes too great for the surrounding rock's tensile strength, the rock holding the strain will eventually break. At this time, the two plates will abruptly reach equilibrium, or a state near equilibrium, forcing the plates out of their current position. A significant earthquake might not happen suddenly. Increased seismicity over the years, foreshocks with a magnitude of 5, may occur before such an earthquake. Seismologists anticipate observing changes in the Earth's surface before the next significant quake, such as the shortening of survey lines across the FaultFault, changes in elevation, and impacts on strain meters in wells. The part of the San Andreas Fault near Parkfield in central California, where a moderate-sized earthquake has occurred on average every 20 to 22 years for roughly the last 100 years, is a crucial place for study on earthquake prediction technologies. There is a significant likelihood that Parkfield will experience an earthquake of magnitude 5 to 6 before the end of this century, because the last sizable earthquake struck in 1966. To understand what changes may occur before an earthquake of that size, the U.S. Geological Survey has set up various devices in the Parkfield region and carefully analyzes the data it has acquired. According to scientists, the San Andreas Fault can cause a powerful earthquake of 7.0 or higher at any time. According to paleoseismic analysis, the last significant earthquake in the southernmost region of the San Andreas Fault occurred in 1726. According to Bahan, a fault cannot actually be overdue for an earthquake, although this one hasn't had one in a very long time. This can signal an impending rupture. Bahan concurred that the longer a period passes between earthquakes, the more time there is for a strain to build up and an earthquake to occur. The researchers had to spend years dating the motion of old earthquakes to determine the fault's slip rate. They used geochronological dating techniques and field mapping to determine the fault strand's motion. They could estimate how much the faults had migrated by mapping and dating rocks and dirt from ancient river channels. This allowed them to calculate slip rates. This clarifies which fault strands are active and likely to result in future earthquakes. Yet, the San Andreas will almost certainly cause a big earthquake in the not-too-distant future. When it does, there will be major devastation and a significant impact on Southern California. But these occurrences are not unfamiliar to Californians, and recently, the state's infrastructure has been built with earthquake protection in mind. The region could be out of commission for a considerable amount of time, so forget about tsunamis and deep chasms springing out. But do prepare for strong shaking, structural damage, fires, and significant economic consequences. As it will inevitably occur at some point, the question will ultimately come down to when, not if. Large earthquake systems, like California's San Andreas Fault, are thought to be propelled by immense forces that are only controlled by friction along the fault that is almost as powerful as the forces themselves, according to years of geological evidence. The idea has been emphasized in textbooks that train generations of Earth scientists, and most geologists today have no reason to question it. But today, the textbooks probably need to be more accurate. However, recent research reveals that the friction that restrains the massive San Andreas Fault is so weak that it would only require the geophysical equivalent of a light prod, not strong forces, to send the FaultFault rumbling in its direction. Yet, the research also hints, albeit hesitantly, that the San Andreas is not about to disintegrate into big pieces. In addition to being weak, the forces that cause the FaultFault are often focused in the wrong direction, according to strain studies along the fault system. The new data may make the San Andreas more or less likely to rupture shortly. Therefore, none of that necessarily means California is better off or worse off. The unexpected findings answer certain long mysterious geological phenomena, but also raise important new concerns regarding the dynamics of the fabled San Andreas system. According to scientists engaged in the study, the findings indicate that significant reorientations of stress patterns along the San Andreas would be required before a catastrophic earthquake could occur on the FaultFault. In the coming years, significant changes in such stress patterns may be crucial in assessing whether a dormant stretch of the FaultFault is ripe for an earthquake, according to Stanford University geophysicist Mark Zoback. Ironically, a deep research well on the Cajun Pass, located just 2 miles from the FaultFault, will be shut down in the coming days due to a lack of funds, which was one of the key methods to reach those results. Scientists will feel uncomfortable with the data gathered because drilling will be stopped just a few thousand feet above the FaultFault, leaving some crucial data gaps. According to Zoback, the project's principal scientist, the well, which is currently 11,000 feet down, has shown that the tension is practically 90 degrees in direction from what we predicted. That would likely push the issue in the wrong direction. In that sense, it's similar to a warning sign. No tension is pushing the FaultFault in the right direction, as should be the case. If we can't prevent it, are there some ways we can actually prepare for this earthquake to reduce its harm? Although there is no perfect way to totally prepare for earthquakes, some things can still decrease the weight of their havoc, and what's more, even keep you alive if, God forbid, you find yourself in one. Fortunately for us, the first is being done by the administrative unit overseeing the San Andreas and the surrounding area, fortifying houses with seismic-proof technological resources. But they still need to do more in the case of old houses. We need to find out how much technology can help in this case, so we must take care. Considering their susceptibility, a program for their demolition should be created to build new ones in their place. Something must be done to them because they are very, very dangerous standing like that. In fact, it is better for there to be no house than for there to be a house. The second one is more or less like the first, but of course, quite separate. New houses should be built with seismic construction systemic methods. We are not talking about technological devices. We prefer safety measures that are part of the buildup of the construction. Of course, technological appliances can also be used to fortify buildings. Now the third is which will be useful for anyone living in this area. It is divided into two. Seismologists must be so nimble that they can predict near-accurate precision when an earthquake will happen. The second is that when such an earthquake prediction is given, evacuate the place as soon as possible. Even if it doesn't happen eventually, you will live to see it. Being out of harm's way in a situation like that is more beneficial. Meanwhile, we must commend the government for the Earthquake Hazards Reduction Act of 1977, which marked the beginning of a substantial program being carried out by the U.S. Geological Survey, other government agencies, universities, and private groups to learn how to forecast earthquakes and assess and reduce their dangers, and we hope this helps. This ultimately shows that it is up to local governments and communities to put protection measures in place. This understanding will be used to create sound regulations that will protect property and preserve lives if it ever happens. And while much is known about this fault, geologists are continually learning more about what may be on the horizon, and it is only a matter of time before a big earthquake happens. Will the San Andreas Fault remain silent forever, or will it be more dangerous than predicted? Let us know your thoughts in the comment section.